Hi again folks, just thought I'd share this with you. I just thought I'd put a little tiny little blob of oil there and there. I mean it's cooking oil, not even engine oil, but I just thought I'd give it a go and give it a spin. The other thing I was thinking about mentioning is where these needle points are. In my air bearing design, there's an air bearing inside here and in here, and there's a magnet in repulsion in the adjuster and in the shaft on both ends. It won't work on this design because the stiffness in here just isn't anywhere near as stiff as an aerostatic bearing. It never will be. And the problem is because these are trying to shift the axle that way and that way, whatever magnet you put in each end, it will overpower it. So it's pointless trying to put a magnet in this end and this end. But what I have found, which I'm going to try, is putting a magnet here and here, a ring magnet, which is repelling off there and there. And I think that would be quite interesting because I've already done a little bit of experimentation with that, and it might work, but it might not. But the thing is, it has much further gap from here to here and here to here than a magnet here and here, which just won't work. You can see it rocking backwards and forwards now. And just that little tiny bit of oil from there and there. It doesn't even want to drip off. I mean, it was literally just a tiniest little drop. But, yeah, I mean the good thing with the air bearing in this one and this one, and magnet and repulsion there and there, you know, apart from the air friction, it will be frictionless. Yeah, and a lot stiffer. We've got a design to allow self-centralisation as well. I did cover that on some CAD drawings on my YouTube channel. It's basically one of these is split in half, and it's made out of acrylic, just so you can see what's going inside. And it's got an aluminium housing with a graphite insert, and around the graphite, around the aluminium housing that sits inside the acrylic is some silicon tube, because it's flexible, and it will allow the bearings to self-align. Because your main problem with any almost frictionless bearing is alignment. So yeah, so that concludes the testing on this one until I've got a proper axle and a rotor. And yeah, it should be interesting when we put some air into the turbine housing and spin it up to some high speeds. There's not a lot of bearing friction going on there. Even less actually when I stand it vertically. It's actually even less. But I'll show you that once I've sorted these ends out. I'll show you that. Okay, all right, cheerio.